So part two, working on the cluster. This is probably what most of you are doing a lot. And like I said, there are some quirks to this, but generally speaking, bioinformatics is becoming a job of processing bigger and bigger data sets. So like instead of processing maybe some RADSeq data, people are processing like terabytes and terabytes of data. And obviously using a cluster for that is really important. And working within the bounds of the cluster means that not only does nobody get in trouble, but things run as efficiently as possible and they are reproducible, which is also really important. Again, when you're working through this, if you've logged off for any reason, you can just log back into the cluster. Here's a suggestion. The cluster that we'll be working on, this Saga cluster, runs using Slurm. So that's the organizational structure of the cluster itself. There's a wiki here that I put a link to with all the documentation. So if you're working later on in the workshop on your own data, you run into problems with different environments, you can refer to this documentation. Everything is in there. It's a bit difficult to navigate some bits, and it definitely took even us organizers quite a while to figure everything out, but it probably is in there. And these wikis are always a good idea, also to look at what the requirements and the structure of the cluster is, because there are often things like constraints on the number of jobs you can run at one time, the memory requirements that you can use, the CPU resources. Sometimes those things are specified and they are like hard limits. So I've worked on clusters where jobs just they'll be killed if they exceed the things that you've told them you want to do for the safety of the cluster and data on it. There are some clusters which I've worked on which don't do that. And with those, you run a much higher risk of causing problems for yourself and others. So it's always a good idea to familiarize yourself with the cluster, particularly the job queuing system and submission system. On this cluster that we'll be working on, you can see which jobs are running using a command like sq. So yeah, some of you might be familiar with something like a B subsystem where you would do like BQ or something. And this is Slurm, so we have a sq. You can then, I'll actually show you what the output like that looks like. So this will list basically every job that's running on the cluster. It will tell us what the job is doing. Let me just zoom out so you can actually see anything on here. Yeah. So it will tell us who's running the job, normally the like wall time, so how long it's been running for, which nodes they're actually using, I presume this is what's in this column, and then probably what queue they're in. So I think this is probably saying that they're in a normal queue, and it will have a job name. So people who use informative job names are great. People who don't probably should. So yeah, you can see this person is probably using some package called, I don't know, NIF2. But this will help you establish like how busy the cluster is, if you need to wait to run things, whatever. You can then filter this output somehow by giving sq a number of flags, so like -j, -w. This will tell you which job IDs you want to look at. So if you are running like a genome assembly, you might go home for the evening, and then the next morning you might want to check on it. You would then be able to run sq and the job ID that you know your job is called. You can also search for different projects. So if you have maybe many genome assemblies running as part of your project, you can see how your assemblies are running. You can even look for users. So like if as a system admin on different clusters, this is what I use to check who's misbehaving on the cluster, for example. You can see who's doing what and why. And you can combine these. So you, like most flag-based commands, you can combine and specify as you wish. So often you just want to check what you are doing, but you might also want to see what other people are doing. Let me just make this viewable again. Now, we are going to kind of go off of the previous script that we had, and I'm going to show you how to submit a very basic script. So this is now not being performed on the login node that I'm on, but it will be executed by a computational node within the cluster. Yeah, in case you're not familiar, clusters are essentially many, many computational nodes connected in some kind of network formation that allows you to basically specify which nodes are executing which jobs. Means you can parallelize jobs. So many jobs in bioinformatics that we use can be parallelized to some extent, and you can basically split the workload amongst many nodes to get it done quicker. Things parallelize differently. That's also worth bearing in mind. But for what we're doing now, don't worry about it too much. So we're going to make this script. And I will then go through what this says. So as before, as somebody very rightly pointed out, I didn't have the shebang in one of my scripts. So here it has the shebang and it's saying that this is written in bash. And the way submission scripts work is you can specify the parameters of the job you're submitting within the script. So in this case, this is saying to sbatch, which is the job submission system, this is my job name. So I call it test. The account that I'm on. So in this case, you'll all be using this project number, which is for this course. Then you can specify a wall time limit. So this is in days, hours, minutes, seconds. And then you can specify a memory requirement. In this case, it is 4 gigabytes, I guess. These will all need tweaking depending on how specific your cluster admin might be. You might get sent emails if you use the wrong parameters. You might just really annoy lots of other people using the cluster. For example, if I'm running, if I'm downloading something, I probably don't need to specify a massive wall time. And if I do, it might get allocated to, like a different queue. There's often like very long job queues. And likewise, I don't want to section off like a terabyte of memory for no reason. So that's also bad. I'm not the person to ask about resource optimization. I find it very painful in general. And everybody I've spoken to pretty much it's an iterative process. In this case, we're just pasting a command. It basically needs 0 memory and 0 wall time. But just to get an idea, we'll use this. So all this job is going to do this time is just echo again, hello world. So we can exit our script. And this time what we'll do is instead of using chmod and just executing the script, we'll use sbatch and our script name. So this is just sending our script to the sbatch system, which will then allocate it resources. So if we do this, you'll see that it tells you the job ID. So it'll say submitted batch job and then an ID. And because it's a very small job, it should have already finished. So we can do ls. And you'll see that there's this slurm, our job ID dot out. There are different ways in the script. We could have specified the different output for this. For what we're doing, it's fine. And if we look in that, it's a bit smaller again, you will see all this information that you've been given. So first of all, it tells us when the job was started, what nodes it was started on, and all this other information. This can obviously be very useful if you've done something many times or you're trying to figure out, which run was it that I did that one thing in? This is often in the output. Here is obviously the output of our script. And actually this cluster is really nice. This isn't definitely on every cluster, but this will tell you what the resources were that you used. So this is telling us basically that we used none of anything, which is as we would expect. It's a very small job. And that we had one task. So I think here, if you were to, there are certain ways of initiating sequential jobs, for example. This would tell us how many tasks that we gave it to basically do sequentially or something like that. One of the things which you will also be doing as part of this workshop is loading environments. Obviously, right now, all we've been doing is using the bash language itself and interacting with the submission system. I think everybody is using either pre-installed software or Condo environments. I don't know how many of you are familiar with Condo environments, but a Condo environment, when it works, basically provides the computational environment to use and interact with the program that you've given it. Condo environments are a bit new to me, actually. I didn't have to use them on the previous cluster, but they're nice in the sense that if you give it one program that you want to use, there will often be a kind of Condo recipe that you can find online. And Condo will basically then install your software and all of the other softwares that depend on it. So it's a bit like installing a package in R when it then pops up and it says, oh, this package also needs this package and this package, and it will install it all for you at once. That's a bit like how Condo works. And you can then activate that Condo environment. I won't go through this beginning bit here, but basically what you need to do is configure your own personal environment to be able to install things on Condo. This is one of the bits which I suspect we might have some issues with, but we can fix those as and when we reach them. But basically what you want to do is, this is basically saying that you kind of want to refresh the state of your environment. So this is just a good starting point, just to make sure your environment is clean. Then you want to make sure that you've loaded Conda itself. And then you can load mini Conda, which is kind of the way that Conda will be able to interact and download packages. You can then initialize your environment using this init command. And this is just telling Conda, look, you're currently working in this bash environment. And then we can start to add things that will allow us to download Conda packages. So here, all of these Conda config commands should just allow you to access kind of these different libraries. And for the exercise that we will go through, the library that I want you to make, or the Condo environment I want you to make that you will interact with, is called fastp, because we'll be going through the read processing that I just explained in the talk. So in this case, what you can do is you can create a new Condo environment called fastp. You can activate that environment. So you have to, before you want to make changes, you want to be within that environment. So if we do conda activate fastp, you will see that now, instead of saying base, in this brackets, it says fastp. This is telling me I'm in the fastp Condo environment. So when you do this, this will be like an empty environment. And what you want to do then is install the fastp software. So here, this fastp after the -n is the name of the environment we're in. This fastp, however, is telling Conda, I want you to download this program and the dependencies. If you click on this link here, you will actually, I can just show you. So this is often, if you were to search Conda and a software, this is often what you'll get. So it will often be on anaconda.org. And you'll see here, these are two different ways of installing fastp. So they work very nicely. And you can do it like this. You can then, so now we're within the activate fastp environment, see if it worked. Sometimes it won't, but let's hope that for all of you it does. In this case, we're just supposed to help sheet. So if this works, we're given the help. So this is telling us like fastp is working. It's a bit hard to see here, but if I zoom out, you'll be able to see. This is what you'd normally get, you know, when you run a software, and it tells you all the different options for how to run it. So if we want to leave the Conda environment, which is something you might want to do, you can do conda deactivate. This. You'll see now we're back to base. One thing to be aware of is I don't think it's very good practice to keep activating Conda environments from within other Conda environments. So if, for example, I wanted to use fastp and something like, I don't know, somebody's mentioned it earlier, like BWA, and I'm going to want to use those kind of in the same session, instead of making a Conda environment for one and then the other, what I might want to do is I can actually load both BWA and fastp within the fastp environment. So this can be useful for things like genome annotation. So when I do genome annotation, I have an annotation Conda environment, and that has every program loaded that I want to use for annotation. It stops me having to jump around Conda environments. And it also means I'm not running into this kind of hierarchical problem of being within Conda environments within Conda environments. If you do that, you can run into problems with dependencies and things like that. On the cluster for all of you to use is a few different data sets. You can explore them a little bit at your leisure once you're logged in. They will all be in this file path that you see here. In this case, we'll be looking at this Saccharomyces data set. And what you can do is, you can run ls and just check that everything's there. So if we look in this file, we'll see that we have these two fastq files, these zipped fastq files. These are gzipped. And most bioinformatics tools these days will read gzip files, which is really good. Stops us having to unzip everything, which is a pain. And you will see that this _1 and _2, this will represent like forward and reverse reads more often than not. And these are the files we're actually going to test using fastq and run QC on. So I'm just going to conda activate fastp. Okay, just to make sure I can interact with them. One of the things you also might want to do when you get a file like this, if you start working on it, is to see like what the structure of the file is. So we can run zcat, which will cat a zipped file. And in this case, you'll see it has this structure that we went through in the talk. So it's saying the number of sequences, the header line, the sequence line, and the quality line. And in this case, you'll see that every read starts with this s at ssr. So actually what we can do is we can do something like this command here. So it will zcat the file. We then pipe it to grep. We extract all the lines which start with at ssr, and then we count them. So this will actually give us the number of reads. And if we execute that, it may take a minute to finish because it's a reasonable file. But eventually it will tell us how many reads there are. So that's something you often want to do. We'll just give it a second. And what we're going to do now is actually yeah, go through how to run this fastp script. Oh yeah, so you see here. So this is the number of sequences. So what is this? 13 million sequences. The way we're going to do this script first, just to make sure your environment is working, this Conda thing, is to run this fastp_myreads test. In the test, instead of actually executing fastp, we're just going to, again, use this help flag. And if the output of the script returns the correct help information, we'll know that the Condo environment worked. Otherwise, we'll get some error that we need to sort out. It's worth noting that throughout this tutorial, there are some things where you'll need to put in your username. I obviously don't want you writing things to my directory. So yeah, you can replace these with your own username. And I will make this script. So you might want to also use the text editor. So you can copy this into the text editor first, because Vim can also be a bit of a pain for things like this. But let's see if this works. Oops. So the way this works too is that this dot here before Conda means that this Conda folder is actually hidden within your directory. So if you were to do ls within this, you won't see your Conda directory because it's hidden. But if you actually ls and then do .conda, you'll be able to see that it's actually there for you. And this line here should just like tell the computer, like, this is what I want to, I want to use a Condo environment before executing fastp. So here we can submit sbatch and our job. And you can see we now have, if we use ls and then just star.out, we see all of our output, and we have the second output files that have appeared. So we can now look in this, and you'll see, oh, this is really annoying. You'll see that actually the output has the start time of the, oops, it has the start time of the job, and then it has all this help information. So unless you can use your spacebar, it will like jump down a page, and then you can see at the end it has what we used. So that's great. That's definitely worked. And now we can go on to actually run the proper run that we want to use. So it's always a good idea to kind of test scripts before you go and run, like, I don't know, alignment of like hundreds and hundreds of genomes, or like mapping and stuff like that. Always test your stuff. So in this case, we're going to now make this new script, which is going to actually have the run in. So in this case, our fastp command is using fastp-i. The little I here gives it the forward reads, and the big I gives it the reverse reads. And then we will just give it an output directory. So again, you'll have to fill in your username. This is telling it that I want it to write the output to this directory. And all of you who are familiar with clusters know that obviously you can replace any of these file paths with any other file paths, which can be obviously very useful. So I'm just going to go through this and make sure all of the username stuff is correct before I accidentally write it to somebody else's output directory. Are there any other questions about submitting scripts on the cluster or anything like that yet?
There's some questions on the chat.
Oh, there are? Could you read them out? Or I can't actually see them right now.
So I was just about to reply to Laura. I was asking, should, well, we said that attendants could copy their own data on the cluster, so we could help them out and analyze it. So right. She's asking whether she should move it to the user, the work user directory, or to the unknown directory.
Yeah, that's a good point. I actually don't know that. Maybe we can get back to you on that. I think you.
No, it's okay. It's okay. I just checked.
Yeah. Okay.
So
you know.
Basically, the home or the user directory has a very low quota, so you will only be able to move 5 Gs of data there, and we won't be able to access it. So if you'd like us to debug it and help you, it's best if you move it to the directory of the workshop.
Yeah, maybe if you have your own data, it's best to contact one of us, and we can make you a folder within that structure, just to avoid everybody having bad file structures. No?
So within the workshop folder, there's an attendant folder and a teacher folder, and within attendant you can make your own folder, I guess, and just keep the data there. Will that be too messy?
No, I think that works fine.
Yeah.
Yeah, also maybe worth mentioning, like, so some of the data you guys will actually be handling is like not published yet. So that's why it's also on the cluster and you can use it there, and it's just kind of for examples, but also just be aware with your own data, like, yeah.
Yep. Yeah, that's a good point.
You kind of put it on there, your own, yeah, like, nobody's going to steal your data, but it's worth just knowing that. I see now the question. So how would you load both BWA and FastP? So for the Condo environment, just before I run this and we go through it, for the Condo environment where you have this Condo install line, so you're within your FastP Condo environment and you're installing software. Here you can just install as many softwares as you want. So if you wanted loads of different software, you just add it all in here. Condo install BWA, Condo install FastP, whatever. Then it should all be accessible within there. It is worth mentioning there are certain programs which Condo doesn't behave with very well, and there's lots of weird quirks. So one that I've experienced a few times is that SAMtools, for some reason, has some weird dependencies. I would always install SAMtools as the last thing that I want to install. For some reason, if you install it first and you install other things on top of it, it doesn't like it. Condo is a bit of a weird thing to get your head around, at least it is for me. At some point, your Condo environment will basically break. And I don't know why that is, but it's basically like things have different dependencies, and sometimes the dependencies go out of date or they need different versions. So you will probably be maintaining Condo environments, or eventually when they get too broken, you'll probably just delete it and make a new one. That's kind of part of it. I really hate it, but yeah, it's essentially just like a version dependency issue. And oh yeah, I just see the other question. Yeah, we'll basically have time in a bit for you to go through this in your own time, I think. Excellent. Okay, I'm going a bit slower than I expected, but I hope this is all pretty self-explanatory. There's nothing too crazy. So let's go back to our FastP run. So we have this script. We're now going to do sbatch and run it. And this one will take a little bit longer, I guess. We can see what the output is. Oh, not a Condo environment. Oh, classic. I made the exact mistake I told none of you to make. So we can edit this. And oh yeah. So here, this should not say your username in massive letters. It should say my name. Okay. And then if we run that, now it should take a couple of minutes. And oh, let's hope this isn't another error. Okay, so now the job has started. So it makes an output file when it starts the job, obviously, and it will keep writing to this output file. So we'll actually see this output file hopefully increase in its content as it runs. I've also given some information here because when this finishes, what FastP will do is it will give you an HTML file. This script here is how you can download HTML files, or any file basically, to your local computer from the cluster. If you reverse these, if you're not familiar with SCP, so this is secure copy. And if you're not familiar with this syntax, this is just saying, this is the file I want to copy and this is where I want it to go to. So if I executed this from my downloads folder, it's saying to here. If you wanted to upload something, you will have to do this in reverse. So you would say, like, this is the file I want to upload, and I want to upload it to here. You will be prompted for your password probably, unless you have a SSH key. And you just need to type your password in, and then it should download. Okay. Let's see. Okay, so I think it's just going to run. It can run in the background. That's fine. There's also the possibility of using arguments in Bash, so you can specify variables and you can make them interact with each other. I'm not going to go through this now because I figure it's like nice for you to have some stuff to work through that's a bit new. But essentially, I'll talk you through what the script does. So this script is a good example, and maybe a bit more like the examples that you'll be using later in the workshop. In that, you'll be working in some kind of Scratch environment or an environment that you want to work in. And what this script will do is it will make a new folder for you using this make directory -p. So this will say, if this directory doesn't exist, then make it, and using this variable here. And then we can specify different arguments. So like name will be the argument 1, and your study species or something will be argument 2. And then this is the bit, obviously, that the computation is actually doing, where it will say, my name is, and then it will use your name variable that you give it and your study species variable that you give it, and it should output the combination of the two. So the way you would submit a script that has this kind of notation, where it's using user given arguments, is you would do sbatch, your script name, and then, for example, your name and your study species or genus. And then you can see that it will output this file using these two variables. So you could do something like, if you were using the fastp script, this $1 could be your forward reads and this $2 could be your reverse reads. And here you would just specify two different file paths for those. And you can look at this output yourself. And one last thing that I just wanted to show you is that it's also possible to run an interactive node. So obviously now, like I said, we're on a login node. I wouldn't suggest you do any proper computation on a login node. But what you can do is still have this interactive infrastructure, but you're running on a node that is capable of computation. And I will try and show you that. So here you use srun, and then you specify the number of CPUs, the memory that you need, how long you want it to run for, etc. And hopefully if we run this, it will wait a bit as you get allocated to a CPU. And you will see now that instead of saying login, I'm now on C5-47. So this is saying I'm now on a computational node. And from this, I could do things like, I don't know, zip or unzip really big files, or do any kind of basic big file manipulation that I'd want to do. And here you can again activate Condo Environments, although we need to figure out how to do that and make sure it works fine. Because obviously now we're in like a fresh environment again. So I will actually test that before you guys need to do it, I think, for some of the other organizers' workshops. But yeah, I think that should be everything. I've put some links down here for further reading for you. This is about bash things and yeah, Unix scripting in general. It's maybe worth saying, if you're on an interactive node, you can just do exit, I think, and you should, yeah, now you're back on the login node. So just so you're aware. Are there any questions?